board. All right, so we're going to review all the descriptive statistics we've done by looking at the data collection, survey data here. And I've mentioned this before, whenever I collect data, whether I collect it or somebody else gave it to me, I never edit the main tab of the sheet. I always make a copy of what I'm going to mess with in another one. So you should see there's a second tab at the bottom next to form responses. It's called gender age. So I took the gender and age columns, made a copy, and I stuck them in here. And I already did a bunch of work here, so I'm just going to review how I made those calculations. You're going to do something similar for the take-home exam. But the big thing here is, what do these numbers tell us about the data? So that's really what I want to get at. Typing the right formula isn't as much of a big deal. So let's move that out of the way. Oops, try that again. There you go. So I have a gender column and I have an age column. The first thing I did was once I brought them in there, I decided to put the gender column first. So I just switched the columns and then I sorted them first by gender. And then in the genders, I sorted by age. And I can demo how to do that in a spreadsheet quick. So highlighting, just grab all of the data you want. And so I just got to find the end of the spreadsheet here. All right, so there's the end of it. I'm going to copy that. I'll do another tab. So just some spreadsheet tricks. The data I give you for the take home is already mostly sorted. When you click on a spreadsheet, you have different options. Like if I click on the cell gender and then I move to the end, I go from a pointer to the hand and I can move that thing around the screen. It turns out if you do the same thing with a column, if you highlight a whole column, your cursor turns to a hand and then you can just drag that column and put it somewhere else on the sheet. So I can easily switch the order of the columns. Early on in the course, I mentioned that when you sort the data, you should select the headings and all relevant data. Oops. And my recommended way to do it is under data, sort range, and then go to the advanced option. So there's a review of something we did back in week 1. And then under advanced, I say, hey, this has a header row. I would like to first sort the genders. And then I'm going to add another sort. Once the genders are sorted, I want to sort by age so that the females will be in order of age and the males will be in order of age. And this kind of sort is important because that means the female that's 44 at the end there, she and her age stick together. Okay. And this kind of sort is important to make sure that happens, that I don't accidentally separate the variables for a case. So that's what I did before. And once I did that, I can see, oh, there was a male who didn't enter an age. And there were a few females here that didn't enter an age. And for most things you do in a spreadsheet, the spreadsheet ignores blanks, but sometimes they are in the way. So just note, when I did this here, I actually deleted the 3 females that didn't have an age and I deleted the male that didn't have an age because I can't use them. They don't have the information I need. Okay, so I did choose to delete those. In a spreadsheet, there's a command for counts, which is just COUNT, right? Count. And then you tell it what to count. And the count function counts numerical things. So it's going to ignore the word age in that column that I gave it. And that is always something to keep in mind. When you use a formula, is it safe to select the whole column? Mostly it is, but sometimes it isn't. You always have to make that judgment call. Mean, what's the other word for mean, especially on a spreadsheet? It is average. Yeah, so in here I have the average command I use to get the average. Standard deviation, you have 2 options. I chose the stdev.s command. S stands for sample. Never, ever, except maybe once in a lifetime, will you do the one called .p. That would mean you have the entire population, which we almost never do. The stdev without anything else does the same thing as the .s. I usually do the .s in case somebody brings this into Excel. Excel likes the .s better than the other one. So for Excel compatibility, I choose the .s version. Does anybody recall how to look for outliers? That's where I'm talking about lower and upper next here when I'm talking about the mean and the standard deviation. Yeah, 2 standard deviations from the mean. Okay, so I'll just make a little note here. Outliers we find by taking the mean, and then we do either a plus or a minus 2 times whatever the standard deviation is. So the lower would be the mean minus 2 standard deviations. The upper would be the mean plus the standard deviation. And if I look at those next 2 calculations there, you should see the first one, I take E4, which is orange for the mean, and minus 2 times cell E5, which is purple for the standard deviation. Whenever you do formulas that reference other cells, always go back to the formula and double click it to make sure you did get the right cells, and it'll color code stuff for you. Because I think you've seen me in class before actually accidentally click on the wrong cell and I messed up the formula. So always double check that. It's easy to make those little mistakes like clicking on the wrong cell, especially like with a touchpad on a mouse, on a laptop. So what does this information here tell me? Well, let's take a look. I'm going to grab this, a picture of this here. So let me get a screenshot. And side note here, whenever we do a graph, we should make sure it has some reasonable labels. So I'm going to use some of the information I just calculated. Specifically, this part right here. Come on. So the lower, right? So this is what we call this, the 2 standard deviation rule right here, or the 95% rule. So 2 standard deviation rule. It's also known as the 95% rule. And what it tells us is that we, for most data sets, we expect about 95% of the data to be between those 2 numbers right there. Is it always going to be 95%? No, it could be less, it could be a little more, it just depends on the data set. So then over here, I'm just going to make some marks. If that's 20 and that's 15, 7 is probably way over here. So way over here is about 7.49. That is my mean X bar minus 2 standard deviations. And then 29.12, here's 30. So that would be right here. 29.12, and that would be the mean plus 2 standard deviations. That is not right. Okay, I have an error in my calculation. How do I know it's not right? Well, the mean is 27 and I'm at 29. It should be the mean plus 9.8 twice. So I messed up a formula. I have the 2, but somehow I missed the times there. All right. 46.74. All right, that seems more reasonable. Come on, eraser. Weird. All right, so it should have been 47.7 or 46.74. So 45, 50, probably right about here. 46.74, and that is the mean plus 2 standard deviations. So this is what we call the usual range of data. Anything outside of that is unusual. So that means I have some numbers out here that we would consider outliers by this rule. To figure out who the outliers are, I actually have to go look at the table of numbers and say, oh, this many are outliers. And so we can identify those. So any number over 46.74. So if I look at the females who are in order here, it's unusual for a female to be over 46, 47 years old. All right, so this group of females right here, I'm going to highlight them. These are in the unusual range. And then for the males, we only have a couple. Now, this sample right here, by the way, is a very biased sample. It is a sample of students that take statistics from me. And I teach statistics in 3 different classes. I teach it in Math 243, I teach it in Math for Elementary School Teachers, and I teach it in Math 105. So anybody that took those classes from me in the last 5 years filled out this survey. One thing to notice is I have far more females than males. About 3/4 of the students that took this were female and about 1/4 were male. That's a little higher than the average. I think the average at the colleges is like 60% of our students here are female and about 40% are male. Okay, so somehow in the courses I teach, Math for Elementary School Teachers, Statistics, and Math and Society, there's even more females than on average in the rest of the college. Is it because of those courses? Is it because I'm teaching them? I don't know. So part of the job here is when you get your data set, you're going to make all these calculations and you're going to say, well, what does the data tell us? And like right away, I can say, oh, wow, 3/4 of the population of the sample here are female compared to the 1/4 that's male roughly. That's a significant observation, isn't it, when I compare them? All right, let's see. My guess is since I messed up the upper calculation here, I might have messed it up here and there. I messed up labels. Okay, which ones? Where are you looking? On the charts? Oh, 2 females. Okay, so it should be female, and then this one here should be male. Thank you. Oops. Got it. Good catch. All right, so let me fix those other 2 formulas. And when you do these, so I'll just demonstrate, let me fix this one. Multiply by that. So always check your work. For example, to do the female standard deviation, to enter that one in, sometimes you can fill formulas one way or another, but only if they're grabbing the same set of data. Is the set of data for all the same as the set of data for female? The answer is no. So for example, for this cell right here, what I had to do is say, okay, what's the ST? I start typing STD. I like the .S version. Should you ever use the .P version? Never, right? And then you have to go select the right data set. So I only want to select the female ages for that calculation. And so there's really not much choice but to drag. There are some special commands where you can say only grab the numbers that have female next to them, but they're harder to use. I'm not going to go over that here. And then similar for the males. To get the male standard deviation, I had to go equals, start typing ST, find the standard deviation S, and then go down till you see the males and select them. You can't do the summary statistics easily unless you sort males and females. Okay, so if your data isn't already sorted by the categorical variable, that is something you definitely have to do. All right. All right, so again, the idea about the lower and upper here, the first time I do this, I'm using the 95% rule, which is also known as the 2 standard deviation rule. And anything outside of that lower and upper range is an outlier. Everything inside it's okay. And I expect you to do that for all of the data, for the males and females, and for the males and the females. Next group of stuff. Min quartile 1, median quartile 3, and the max. Those guys there are what we call positional statistics, because they need the list to be in order to identify where that position is. What does quartile 1 tell us? What does the age 20 mean for all of these people? For the age 20 to be quartile 1, what does that tell us? Cutoff for what? The first 25%. Yeah, so what that tells me is the age 20, 25% of students in my class, these classes, were 20 years old or younger, is what that tells us right there. The median of 23 for everybody, median is the second quartile, it marks 50%. So half of my students are 23 years old or younger. The other half are older than 23. Okay, so that's something significant I can make. I can say, hey, the 50% of students that take this class are 23 years or younger, or you could take it the other way. Now, the commands here are pretty straightforward. We've gone over those before. StatKey will also do these for me. And I can do them one at a time, or I can do them in groups. So StatKey has a few options here. So I'll go over the StatKey versions in just a minute. Remember, Excel and Google Sheets do not make good box plots. Don't even try. They suck. StatKey makes a pretty good box plot. I did a screenshot of the StatKey box plot for all of my data here. I did a StatKey box plot for the females, and I did another one for the males there. So I'll show you how I went about doing those. To use StatKey, you got to copy and paste the data into StatKey to make that happen. And you could use just the ages, or you could use the ages and the categorical identifiers. Doesn't matter either way. So I'm going to go for using, let's say, just the female, or let's do just all ages. So I'm going to go select all of my numbers, copy them, and either you can search for StatKey or it's listed under the home page, useful websites, StatKey. So the question here is, which button do I want to push here? Well, next week we'll start jumping into these other columns, but for now we're in descriptive statistics. And I have one quantitative variable. So that's where I would start. So I could select that. And then I just want to edit their data out and put my data in. And I think all of you are getting pretty good at this because you've done this every week. This version of the data here, I didn't bring in the name male and female for these. So that means there isn't a first column identifier, but I do have the word age at the top. So there is a data row header. And so I can select OK. And I can get a box plot. Now, StatKey does a quick histogram. The only problem with their histogram is it is hard to read because you can't tell unless you point to a column what the beginning and end of the column is. So it's good for a quick look at the data. I can look at that and look at that and say, wow, that's really skewed right. Most people that take these classes are younger. There's a few people who are older. So I'd recommend doing the histogram in Excel or in Google Sheets. I'll review how to do that in a minute. But here, really what I want is the box plot. And screenshots are different on each kind of computer, so I'm not going to go over a screenshot here, but if you need help with screenshots, let me know. All right, I'm going to go back to my data for a second. I could have grabbed, instead of just the numbers, I could have grabbed the genders and the numbers. So I'm going to do it that way this time. And I could put that all right here. And it's really not going to change anything from StatKey's point of view. It's going to give me the exact same histogram. I just need to make sure I check. I have a first column of identifiers, male versus female. And it's exactly the same box plot we just saw a minute ago. However, I don't know if anyone noticed this. This was covered back, when was this? I think it was the last section of chapter 1. StatKey has another place that I can go to play with this. Notice they have an option called one quantitative, one categorical variable. What that will do is where I in here had to by hand compare the males and females with the statistics and my charts, StatKey will do a comparison for me, which is kind of nice. So I'm going to select that one this time. And let's see, how do they want the data? Hopefully I have it in the right way. Yeah, they want the label and they want the value, which is exactly how I have the data there. So I can just go get rid of all this stuff here, put in my genders and numbers. Probably should have picked a smaller data set, but it's okay. Oh, thank you. Control. Ooh. There we go. Control A. I don't know why I forget that one. I'm good with lots of other control keys, but that one eludes me. And okay. So now StatKey will do a box plot. Notice it has my summary statistics. It has female, male, and overall. So it does the quick ones for me, which is nice. And then the histogram, it's kind of nice to see them side by side, but again, we don't have much control over the column width, so that's kind of a problem here. But the box plot is nice to see. I can see them stacked in comparison. And there's lots of things I can say about this now, right? The middle 50% of women who take this class have an age between about 20 and 30. And the middle 50% of males that take this class, they're a more narrow range between 19 and 24 and a half, right? And we can see those numbers here. And we can really see in this range right here. We can see that the males have a pretty long range of ages for the upper 75% of ages, right? It ranges from 24 and a half years old up to 51 years old. That's a pretty wide fourth quarter of numbers. The median age for females is significantly higher than the median age for males, right? So, and again, the females have a much larger range and a much larger interquartile range. Okay, so there's lots of observations. So again, I'm going to give you a data set. That data set's broken down into a category and a numerical value, and you're just going to make statistics and make some graphs and then start telling me, how are these different? How are they alike? And there's always a ton of different things you can say about how they're alike and different. Okay. Let's see, there was something else I was going to, how to do a better histogram. So let's review that. So again, quick histogram is nice here, but the labels are pretty brief. I see the word male, I see the word female, but it doesn't say what I'm talking about here. Are these male and female what? Heights, weights, ages? I don't know. It doesn't show me. In the spreadsheet, we have the opportunity to make a better histogram. So let's do, I couldn't find an easy way to make Excel or Sheets take all of the genders and ages and make a set of histograms separating them out. It wouldn't do that. So you have to make separate ones or make what's called a frequency table, which we did in week 2, but those are kind of a pain. So you could highlight the gender along with the ages or the whatever your quantitative variable is, but since for a histogram, Excel and Google really don't have the ability to make use of those categories in a histogram, it doesn't matter whether you select just a quantitative column or both. I'm going to select both just to show it doesn't matter. So I'm going to insert a chart. And often Google will look at your data and guess at the right chart you want, but it won't always. So if you don't get histogram as the chart, then you should go to the custom type and then find histogram. Now notice it's putting the x-axis as gender. What do you see along the x-axis? A bunch of numbers. Do we measure gender by number? Right, so Excel looked at, or Google looked at what I gave it and it's a little confused about it. The x-axis is not gender, right? Those are the ages there. So I could either just retype that or just pull gender out of the x-axis. It's still the same chart, right? It picked the name histogram of age. Is that a great name? No, I should retype a better name. Do you have to use the word histogram in the title? Nope, don't have to, right? You could call it anything you want, but you just have to say whatever this population is or whatever this sample is I'm talking about. So I would say something like ages of students that take math at BMCC might be what I'm looking at here, or some better title. Google picked age as the name of the vertical axis. Is that true? No, a histogram counts the ages. So this right here should really be either called frequency, count, or even better, how about number of students or number of people? Is it okay that I don't have a label at the bottom here? Nope, definitely have to label everything. So we definitely want to get a better chart title. Something like this would be okay for this one. If I could spell distribution today. And then I definitely need to name the horizontal axis, age. I think most people realize we measure age in years, but sometimes we do want to be more specific and put the units too. But I think, yeah, so that's a good question. So if you look at the numbers on the bottom here, 15, 18.46, 21.92, Google just made some guess as to how to distribute the widths here, but those aren't very nice numbers. So pick a better number. So to do that, we go to histogram, and I'm thinking like it guessed about 2.46. A nicer number compared to 2.46 would be 3, or they guess 3.46. So I could try something like 3. Enter 15, 18, 21. What might be better? 5 or 10, right? So just play around. Let's try 10. 1, 2, 3, 4, 5 columns. Looks kind of blocky and crude. I don't think I like that one either. Is there a best histogram? No, there's just lots of options. 5, 15, 20, 25, 30. I like that one. That one looks good of the 3 or 4 I've tried so far. So play around with it, come up with a better bucket size than what is guessed at. It's easier to do that in Google and Excel than it is to do that in Stackey. And I am out of time for having fun with this. All right, so thanks for playing. What is today? Today is Wednesday. I have office hours at 2 if anybody has questions or needs help. I also have, I usually have an office hour tomorrow at 9, but I have to drive out of town to a conference. If you really need to meet with me tomorrow, then please contact me to schedule an appointment at a different time. I will be glad to meet with you. I get to go to a math conference this weekend. I'm very excited.